So Wireshark is a free and open source packet analyzer. So it analyzes the packets that are being transmitted through the connected network. So whatever is the connected network, through that, whatever the packets it is being sent and received, it will be analyzed by using the Wireshark. It is used for network troubleshooting, analysis, software and communication protocols development, and education. So you can use it for different insights about how the communication basically takes place through a particular network. Okay, whatever the protocols we have gone through in this course, the same protocols will be uh, used for the communication and currently being used for the communication. So all these protocols can be observed through that packet tracer. Sorry, so this wire shark basically. So this wire shark will be helpful just for analyzing the packets. Okay, and also it will be able to troubleshoot if someone is like a network engineer is there. They basically do the troubleshooting or analysis of a particular connection. Okay, so that can be done. And for education purpose, we can use it for basic understanding about our the concepts that we have gone through in this course of computer networks. Okay, so you can download it. After downloading, if you run, so I have already downloaded it, so I will be opening it first. So once you open it, it will be coming out likewise. So here it will be showing out how many networks are there. So different networks that are here. Okay, so here you can just see here like different connections are there through that different mediums through that we can connect to a network. So here basically my laptop is basically connected with the Wi-Fi. So in this Wi-Fi there is a wave coming. So wave means there is a connection. So there is a data being received and transmitted by this network. So we'll be clicking on this Wi-Fi part. Okay, once we click on the Wi-Fi, here different data that is being received will be marked here, or you can just see here. So starting with the serial number 1, this means this is the packet number 1, packet number 2, likewise. So different packets are there. So that are being transmitted through the network that through which I have been connected. So my laptop is connected with the Wi-Fi. So through Wi-Fi, different messages are being sent and it is continuously being observed here. So all the packets you can observe here. Okay. So or any packets that are coming to your system or coming out of the system, that all can be tracked. So this is like it will be continuously tracking. So this continuously tracking. So we will be for now we will be stopping it. Okay, so if we stop it, now it will not be capturing the packets. But you can just see starting with the packet number 1, it has captured within this few seconds only. It has captured 57,311 packets. Okay, and these packets are of different types. These packets are of different types. So here is like whatever the packet has been captured, you can analyze it with respect to its value. So what it is, how its values are been given, what it basically explains here. Internet Protocol version 4. So in IPv4, there is a source and there is a destination, and user datagram UDP source port, because here UDP will be basically used for like sending a data for a particular application. Application specific is there, so there is a source port address is there. So source port and destination port. So these are going to explain like source port and destination is from which we are sending. The source is our system, and the destination port is the application where it is being going. Okay, so all this can be monitored here. Once you will be clicking on this, here the observation of the packets will not be likewise. So what you can go here in the edit, you can go to the preference. In the preference, it is a layout. So in the layout, if you click on this, by default it is in byte packet byte mode. If you click on like packet diagram, so whatever is the data that we will be tracking a particular packet, so in that packet the data will be shown in the form of headers that we have seen in the course. So what headers we have seen? So in the header, different fields are there. So the data of that packet will be shown as per the fields available and the format of the header. So that will be more interactive or intuitive once you look at the packet, and different ways we can compare. So that is the only change that I have done. Okay, so this is the basic about that. And if you click here, if you right click and show values, yeah, so values are there. So if you click here, so different values will be available here. So if it is IPv4, different fields of the IPv4 will be given here. So this is just for a basic understanding about a particular packet. So whatever is uh, the analysis that we are going to do is, so basically we'll be understanding what is the different protocols, how we can analyze its data, and what we have understood in the course. Similar to that only, the data is available here in that format only, the header formats that we have gone through different protocols. And in that, if we talk about, suppose we are going to have like ARP, here it is. So we know the ARP protocols are there. So ARP is basically used for, this is address resolution protocol. So address resolution protocol is basically used when we require. So there is a source. Okay, so there is a source and there is a destination. Okay, so in case of the packets we just have seen, so here there are ARP packets are being used. So ARP, when we basically use ARP, so whenever like there is a source and there is a destination. So while sending a packet from source to destination, basically we require like the source should be knowing the value of physical address. So source, IP address of the source, IP the physical address of the source, and then IP address of the destination, and then physical address of the destination. So physical address in the sense the physical address, it is basically the MAC address. And this IP address of the source will be known and the IP address of the destination. But while sending data, the source do not know the MAC address of the destination. So destination MAC address is not known. In that case, the source use ARP packets. So it sends ARP, and then in reply to this, the destination will be sending the reply with its MAC address to this. So this is basically being used here. So here ARP is being used. So in this ARP, you can just click on any of the packet. If you click on that particular packet here, the data will be coming here. So if you click it here, so in ARP, what is the basically header? If you click on here, so if you go down, okay, so this is the address resolution protocol. So in address resolution protocol, we have seen what is the header format. So this is the data of the ARP. Okay, so in that it is given in terms of field wise, but the same data is being arranged into the way that we have studied. So in that it is like it is of 0 bit here and 31 means total 32 bit is there starting here to here. So there is a hardware type that is of 16 bit means 2 byte data is the hardware type, whatever hardware it is. So it is going to use the Ethernet. So Ethernet is the part of like physical and data link here. So that's why there is a requirement of MAC address of the destination. So to get the MAC address of the destination, the ARP protocol is basically used. So here the hardware type is whatever communication we are taking here. It is hardware, that is Ethernet. And what is the protocol we are using? So IPv4 protocol is being used. Okay, and what is the hardware size? So hardware size means the address of the physical address of this hardware. So it's for Ethernet, the physical address is basically MAC address. So MAC address is of 6 byte. Okay, that is 48 bits basically. So this hardware size is 6 byte, and protocol size means it is IP address. So protocol size is logical address, that is IP address basically. So IP address is of 4 byte means 32 bit. Okay, and what is the type of the request? So it is opcode request. So there are two types of operations basically in case of ARP. One is request, another one is reply. So request and reply. Okay, so this is how it is a request type. So it is requesting the address. Okay, so it is requesting the address. So you can just see this is the first, this is the source. So this is the source and this is the destination. Okay, if you talk about what is the IP address, we need to just check like what is the IP address of the system. Yeah, so IPv4 that is 172.25.49.71. So this is the IP address of my laptop basically. So you can just see here 49.71. So whatever is the data, so the first is basically 179.25.49. This. So something is being sent to this destination. Okay, and here the protocol is STUN. So STUN is here session traversal utilities for net. So that we have not gone through, but yes, that is basically used for some turning some message, sending message basically to the destination. So this is the source, our IP address means our system. Some data is being sent to this IP address. Okay, and then there is a broadcast. So always the ARP message is of broadcast type. Okay, and we will be looking at like is there any, because the reply of this ARP is basically this is the request message. The reply one is always in terms of the unicast. We will be searching if there is any unicast. It's not here. Okay, so type of destination is also based on that we can search. So here there is like different filters are there. So whatever is the message here, different packets are being displayed here. We can use different filters to search out of this house because there are total 57,311 packets. So we can search our packets based on the type of protocol also. We can search it. So it's like suppose there are TCP protocols. If we search it, okay, if we enter, so there will be the TCP protocols. So out of the total 57,311, the TCP protocols are 166. There are 166 TCP protocols are there. So likewise, if any other protocol if you are searching at like ARP protocol itself, if you click it, so it is like 10,688 are the ARP protocols out of the total 57,311 protocols. So different protocols you can search. If you remove the filter, the complete packets that are available that will be shown here. So display packet are this one and complete packet is this. So 100% are displayed here. So we can analyze the data in that. So it was basically the ARP. So we will be looking at some other data. So suppose we are having TCP itself. So or TCP. Okay. So here is the TCP. Okay, we can see here. So in TCP, this is the TCP packet is coming here. So if we click on any value, okay. So now this is the data. If you click on it, you can just see here the TCP header format. So here there is a source port, there is a destination port. Then what is the sequence number? Okay. Then what is the acknowledgement number? What is the header length? Then flag. What is the window size? What is checksum? What is urgent pointer? And some options. So in options there are some data available. So this is how if you open it further, these are the data available in that. Okay. So this is how basically data can be viewed into this Wireshark basically. So here one more thing we will be looking like in TCP, we know like the TCP is basically considered as secure, reliable communication. So TCP is considered to be reliable communication. In reliable, why it is called reliable communication? Because in reliable, it is called reliable communication because we know once there is a source and there is a destination. So when a particular data is being sent between TCP with the help of TCP from source to destination, so before sending the data, this source will be having a three-way handshake. We know it follows three-way handshake. So first it will be sending sync signal to the destination. In reply to that, this destination will be sending a sync acknowledgement, and with respect to this sync acknowledgement, again the source will be sending a sync. So after this, we can say like the connection is established, or we can call it like the source and destination is connected. So same we can observe here. So you can just see here, like here the first, like this is 172.25.49.71. So this is the IP address of my system, basically this laptop. So this laptop is having this IP address. So before making the connections, it's first it is sending this is the source and this is the destination. So this source IP address is sending the TCP packet to this destination IP address, and that is of 66 byte length. Okay, and here it is basically going to give you the port. Port in the sense 60530 is the port of this port of the application that is running on this IP address, the source IP address, and this 80 is the port of the application that is running on the server. This 80 is basically indicating the port number of HTTPS. The HTTPS requests are always having the 80 as the port number, and it is sending a sync signal here. So it is sending a sync signal. So this is the sync signal means it is establishing the connection. The source establishing a connection by sending a sync, and this was the destination. Okay, so the same you can is this is the destination one. So now destination is sending a packet to the source one. So this was the source. Now it is our destination. So now suppose consider this is a server. This address is of a server. Our system. So on that there is a TCP packet is receiving. Okay, so you can just see here the server from server to the port number. So the port number was the application that is running on the server on this laptop basically. So from 80 port to 60530 there is a data coming, and that data is having sync and acknowledgement. So sync was requested by TCP. So before establishing a connection, TCP IP will sending sync. Then there was a reply from the server or the destination application. This is sync and acknowledgement. Okay, and you can see here the sequence number. Here sequence number was 0. Okay, so sequence number was 0. So with respect to this sequence number, the sync acknowledgement was received. So here again sequence number is 0 and acknowledgement number is 1 this time. Next time the source was this laptop. So this laptop is having 172.25.49.71 will be sending a packet again to this server one. So from 60530 is the port number going to 80 port number with the TCP IP packet, and that TCP IP packet will be the acknowledgement. And this acknowledgement will be with respect to new packet, that is new sequence number is 1, and it will be this acknowledgement will be in reply to this acknowledgement one. Okay, so this is the acknowledgement. Yeah, so in the here also you see like it will be like the acknowledgement basically, acknowledgement of this. Okay, so this is how basically a working that we have seen in the theory part is being observed here. So you can just think in that way. So different. So this was the case with this. So each time whenever the data is being sent, it will be sending hand-checking signals, and then it will be sending the data numbers. Okay, so this is how basically the TCP IP can be observed. Okay, so further we will be looking at some other. So in TCP IP we can see here, and also if we talk about the IPv4, so if you click on the IPv4 you can see it. So IPv4 also, so IPv4 is its header format we have already seen. The same header format is bit value which is given. The first one is version 4, header length is of 20 byte, and then differentiated service field. So here the service field is there, the 00 value, total length is 52 byte, and then identification, then this is the flag, this is the fragment offset, time to leave, and the protocol is basically using TCP over the IP. Okay, so this is the TCP is being used. So what protocol it is? So TCP, and header checksum is given here, source address and destination IP address is given here. So this is how we can observe everything by using this Wireshark software. Okay, so we will also see some packets if it is any DNS. Okay, so there are DNS packets are also available. So in DNS we know domain name service. So for what purpose DNS is basically used? So DNS is used basically for getting the IP address with respect to the domain name. So you have different packets are there. So how many? 4 packets are there out of total 4 packets are for DNS. So if you click here on the first one, yeah. So in domain name basically there are query packets. Okay, so always there will be a query packet. If you click here, you can just go here. Okay, so how the query is there in terms of response is like this is the WhatsApp. Okay, so you can just see here how this query is basically being done. Okay, so in DNS query it will be sending the IP address with respect to this query. So it is always a query, so it will be always the name. So whatever is the WhatsApp name, so this is just sending this query, like this is the domain name, and with respect to that what is the IP address. Okay, so if you can see, yeah, so here is the header format in case of domain name. Header format is basically like while sending the data in that particular protocol, how basically the data is being represented. If we are sending a 4 byte data, so how out of this 4 byte, what is the first byte indicating, what is the second byte indicating, everything will be explained with respect to its header format. So here this is the domain name service, domain name system, basically it's a header format. So that's why header format in terms of all the protocols that we see, basically the header format is one of the important thing that we should be focusing on. Okay, so yeah, this was the case. So okay, so you can see here, so this is from my system basically. So this is the IP address of the source, this laptop 172.25.49.71. So this has sent a request to this destination with a DNS query. Okay, so the same you can see in the next packet, it is observing like the source is now this server. This is suppose the server, WhatsApp server or whatever. So this is the server. So this server is replying to this source with this message. Yeah, so we will be looking at the data. This is the query and this is the response basically. So there was a query and with respect to that there is a response. So query was for whatsapp.net, g.whatsapp.net. What is that? So with respect to that there will be an IP address. So it will be replying with the IP address for that. Okay. So it is basically its data is given. Okay. So different other details are there about that, and you can just see with respect to that it is going to say like what is its type, what is its class. Okay. Name, length, level count, and all. Okay. So this is the answer. So this was the query, and with respect to that there was a reply or response that is written as answer. So in that case, g.whatsapp.net, this different data is there with respect to that. At the end, it is basically going to name. This was the address, and then there was a reply. So reply was basically the address 157.240.16.53. So the address is basically this, and the length is data length is 4. So 4 byte. Okay. So this is, and time to leave is given also. Time to leave we have studied. So with respect to that there was a response. In that response there will be an IP address with respect to that domain name. So this is how the DNS protocols we can monitor here. So in real communication, basically this is how the data packets are basically sent. Whenever we click on like g.whatsapp.net, it will be decoding its name, this domain name, with its IP address, and communication will be taking place with respect to IP address. Okay. So if suppose we want to find out like 157.240.16.53. So this is 157.240.16.53. Suppose this was the IP address. We want to find out this IP address here because there are total 57,311 packets. We have stopped this. This was the packet recorded in within 10 seconds only. Suppose we want to find out that IP address. Okay. So if with respect to that IP address, if you want to find out some packets, so IP, we will be writing like IP dot address, and we will be naming here the IP address. So IP address was 157.240.16.53. Okay, so these are the number of packets that have been sent and received by the source device, that is this laptop. This is 122.25.49.71. So this was the source device, and it is sending the TCP data with respect to TCP. So it is sending to this IP address, and this IP address is for WhatsApp.com. Okay, so from here to here, the data is being sent. So before sending the data, again here it has done the sync and then sync acknowledgement and then acknowledgement. Then it is sending the data push. Okay, so this is sending the data now. So then there, sending the data, then there is acknowledgement, then sending the data and then acknowledgement likewise. So what is the sequence number? Here the sequence number comes. Like whenever the data is being sent, so with respect to that there is an acknowledgement. Okay, so likewise, the analysis can be done here. Okay, so this Wireshark can be used for that also, to get different filters and to analyze the different packets that are available here. Okay, so suppose okay, so till here, so in terms of DNS we have seen. Okay, so suppose we want to find out the DNS dot count. So there are different filters already available. You can just go to different filters and analyze the packets basically. So, queries. Yeah, these many queries has been done with respect to DNS server basically. So different query messages are there that have been given total. So total 17,173 are the total number of queries that have been done for different protocols basically. So you can search likewise also. You can search suppose. Okay, so this was the case. Suppose we want to search for suppose any for any query that is for suppose google.com. Suppose through that is there any time that I have searched for google.com, then we want to find out. So DNS dot query dot name. Okay, no queries there with respect to google.com. So we want to just see there was whatsapp.net, g.whatsapp.net. Okay, so it is like for any website, if you want to find out whether there is any query with respect to this website or not. So there was some query with respect to that website, so that you can also use this filter to find out. Okay, suppose you want to find out any ICMP packets are there. So ICMP. Okay, so there is no ICMP packet. So ICMP packet will basically use when there is a ping command. So we'll just see if there is any ping command. So can we can find this type of. So this is like analysis you can do for different packets that is received. So here, yeah, some UDP packets we will be looking at. Okay, so here if you click at UDP packets, you can see here. So this is the UDP data. The header format is basically given. You can click it further. You can see this is the code, source code, destination code, and then the length. What is the checksum? And likewise, there are different values given here. Okay, for UDP, ERP protocols. So the protocols, important protocols we have seen. So you can just search here and analyze it. So what we will be doing is we will be you can save this file also, and after saving you can analyze it, or you can save these files into a CSV format, and you can apply some machine learning algorithms to find out like how many packets of particular category are being received and what is the data. You can analyze it further. Okay, so either you want to save it or not, we will be continuing without saving. So again, the packets are being have started receiving. So what we will be doing is we will be searching for like suppose youtube.com. Okay, so suppose we have searched the youtube.com. So you're just looking at, yeah, we will be stopping here. So we have clicked on youtube.com. Okay, so we want to search for DNS dot. We will be looking just the DNS queries and where it is youtube.com. Okay, so if we want to find out the DNS queries with respect to youtube.com, so we just whatsapp.net. Okay, thank you, we need to. Okay, we can stop it, and then we will see DNS dot. DNS queries test. It has recorded them. Okay, so it has not recorded that. We need to further run it, and it may be recording. Okay, and also suppose we want to do some ping command. So cmd. Suppose we want to ping youtube.com. Okay, so this ping command is basically going to use ICMP packets, so that will also be recorded. So youtube.com, or we can directly ping a particular ping is basically used to check a direct connectivity between the system and the destination address. So youtube.com, it is getting sending an ICMP message, and with that there is a reply. So it is able to record that reply. So it is four packets are sent and received. So there is no loss. That means it is connected, directly connected. So this is directly connected with the YouTube in the terms of the connectivity is there. So that we can just, that is there. We will be stopping further now. Now we will be again checking it. So DNS query. Is it any? Yeah. So for youtube.com there is a query. So that we have connected. So the same whatever you are doing on this system, and it is this system is basically sending any data through the network, that is the Wi-Fi network we are connected with. Then through Wi-Fi any data is being transmitted, that will be recorded here by using the Wireshark. So if we have gone through the youtube.com, so it is going to have the DNS query basically. Okay. So for that, for YouTube, this is our. Okay. So I think When you check again. Yeah, so now the IP addresses have been changed. So basically, why does this IP address is being changed? Because if you click it, yeah, IP assignment is basically automatic, that is DSCP. So DSCP is the dynamic assignment. So if it is dynamic assignment, it will be keep on changing the IP address. So previously it was different and now it is different IP address. So if you click it here and then instead of DSCP, if you click on manual, so IPv4, you should be able to set the IPv4 by step also. But for that, there is a suppose we want to have 192.168.10.21 suppose. So with respect to that, we need to give the subnet mask. So for 192.168, 192 means it is a class C type of. So for that, 255.255.255.0 will be the subnet mask, and we need to provide the gateway and likewise. What we don't have, so it will not be taking. So we should be knowing the gateway, like what is the default gateway here. Once we know the default gateway, then only we will be able to set it. So we don't have the default gateway, so we will not be able to set it. The static one, if we know the default gateway, we can set it. Okay. So this is where the default one, the because it is in DSCP mode. So by default, IPv4 address is 172.25.238.24. So yeah. So here 238.24, this is the source one. This is going to a destination this, and this is the DNS query, and with respect to that, there is a response. Two queries are there, two responses are there. So this is how it is there. Once you will be clicking on any link, it will be going to display that packet here in the Wireshark. And also, if you want to find out, because we have done the ping command, so ICMP will looking like, yeah. So we have done the ping. We have used the ping to the YouTube. So it is, so ping basically uses the ICMP packet. So ICMP we have used like it basically gives the reliability to IP addressing basically. So in IP addresses, IP protocols that we use for sending the data, it is unreliable, but ICMP basically creates a reliable communication by sending a request and reply, and by tracking any errors are there. So error control we have seen, and the query messages. So here in ICMP, you can just see here there was a ping. So we have used the ping. So there was a ping request. Okay. So with respect to that ping request, there is a reply. Then ping request, reply, request, reply, request, request, reply. So whenever we basically go for ping command, it sends one ICMP request and there is a reply. Then in one ping, it will be sending 4 requests and 4 replies will be obtained. So that's why there are 8 commands, 8 ICMP protocols are there. So if we click it here, you can just see here ICMP protocol. If we click here, its data we can also see here. So if we IPv4, ICMP. In ICMP, this is basically the header format. So in that there was a type. So this type is basically going to say what type of message it is. Okay, what is this code? Code is going to indicate what is the why this message, what is the reason behind receiving this message in case of request. And also this will be the checksum. Checksum value will be indicating the addition of all the data. So 8 plus 0 plus this value plus this value, and then after adding we need to complement, then we will be getting the checksum. Okay, so this was there. So with respect to that, and here the data case is also given. So what is the data? The data is there. This is the data in there. Okay, so the data is like the data will be with respect to the, if there is any error, this data will be decided as the origin packet headers basically. But in case of there is no error, if it is request and reply is there, so request and reply is there, in that case this data will be specific to that message basically. Okay, so that is there. So we have seen all these things in that in our course also. Okay, so with respect to that request, there will be a reply. So if there is a reply, so in that case you can see here. So in reply, the type of message is 0 and the code is 0, and likewise the values will be changing. So this is how the ICMP message, ICMP protocols we can see. Okay, and also we will be looking at like HTTP. Is there any HTTP? So there is no HTTP protocols are here. Okay, and we will be looking at HTTPS. There is no HTTPS. Okay, so what we will be doing now? We will be looking at one. We will start. We will be starting the tracking of the packet. Now we will going for a link that is this. So this is a link that is not a secured one. That means it is not using HTTPS. It is using HTTP protocol. So you will be just clicking here, and then suppose there is a username and password we are sending. So it is going to say like there is an error. So but whatever the data we have sent, that will be recorded by this packet addresser. So this was an HTTP request. Okay, one HTTPS request will also will be looking at, like suppose we are having gmail.com. So it is HTTPS is there. Okay, so if it is HTTPS means there will be some HTTPS packets will be sent. Okay, and then there will be some HTTP packets. Okay, suppose in that any value we can just put it here. Okay, any password we randomly put it. Okay, so that we have sent. It should be recorded by the packet addresser. Now we will be stopping it. I hope it is recorded. Or next also like here 1 2 3 4 5 6 7 8 9 0. So suppose this we have sent. Okay, then we will be recording. So this packet have been recorded, I hope. Now we will be stopping it. So this is the packet now that is recorded. Okay, so after that we want to find out HTTP. Is there any HTTP packet? Yeah, so there are HTTP packets. So here is the HTTP packets, and on where we are logging it. Okay, so we want to just see on that. So this is the HTTP packet. We will see whether we can just click on and then follow the HTTP string. Here you can see like is there the value username and the password value. Whether we should be able to see what was the username. we just want to, yeah, here you can see here. So once here you can see here, text username was admin and text password was the admin. So this is like whenever we are going to use any HTTP type of protocols. So if any website is there that is having only HTTP type of protocol, in that case, whatever data that we are sending, anyone can observe that data. So as is available here, by analyzing the packet that is HTTP packets are there, so that we can analyze it and we can see here is like the username and passwords are reachable. Anyone can track that and they can know your data. So even if it is bank details, it should be able to be tracked by a particular packet analyzer. Okay, so here if it is HTTP, the packets will be containing data that will not be an encrypted one. It is not an encrypted. It is directly available. Anyone can see it. So this is the HTTP. So if we want to find out like HTTPS is there. Okay, so we're looking like. Okay, we don't have any like HTTPS packet, otherwise we should be able to see whether named HTTPS. So we are having just 4 packets, that is for HTTPS. For if any HTTPS type of packets are there, in that case, the values that are clearly visible, the username and password, that will not be available, like that will be in encrypted mode. So that's why it is preferred to use HTTPS, not HTTP type of website. So those websites that are not secure, that are using HTTP, that should not be used, and otherwise we should not be also sharing our data with that. So because that is not secure because we will be able to observe the data that is going through that type of protocol. It can be observed clearly by anyone. That's why it should not be used. Okay, so this is how the different filters can be used. Again, different filters are there. Like if suppose a particular you want to see different packets, but you don't want to see the TCP type of packets. So not the TCP. So it will be showing all other packets that are not having TCP content. So all other than the TCP packets will be observed. If we are having not TCP and UDP, if it's C means it will not be showing TCP, but it will be showing UDP packets. So UDP and not TCP will be so. If we say not UDP, so it will be showing the packets that are not UDP and not TCP. So other than the UDP and TCP packets, it will be showing all other packets. Okay. So this is how different filters can be used to identify here. Okay. So I hope you have got something from this. So just go with this things and search it further, like how we can further use it. Okay. So I hope you have got something from this. Okay. So what we will be having is we will be having like 1 to 2 experiments by using Wireshark also. So I will be giving you out 2 experiments. So one experiment will be with respect to like using the ping command, observe the ICMP packet, and then using the HTTP website and then observing the packet. Okay, and then using the DNS one and then TCP/IP and UDP packets of data of a packet that is going to this network. Okay, so that we will be having 2 to 3 experiments basically on Wireshark also. So you can just search it further, and to set this, you need to go to view and in the edit and then preference, you have to go to layout and then packet diagram. In that case, this type of diagrams will be appearing. So I hope you have got the point.